Hello and welcome. If you're just joining us, we're just going to wait maybe another 30 seconds or so to let folks join in on the webinar, and we'll be getting started shortly. All right, so let's go ahead and get started. Welcome, everyone. Good morning, good afternoon, good evening, wherever you are. But I'm glad to have you here today. We're going to be walking through some of our top signals from our 2026 Device Intelligence Report and talking about how fraud signals cluster in global traffic. Now, a few housekeeping things. Let's make sure we got the slides going. There we go. A few housekeeping things here. Go ahead and drop any questions that you have in the Q&A panel. We'll be going through the session, and at the end, we'll look and see what questions are there and answer them at the end. But if you have questions along the way, make sure you pop them into that Q&A. And this webinar is being recorded, and the recording will be sent to anyone who registered so you can have it to reference later. And then also, there are captions available. You can just toggle them using the CC button that you should see in the Zoom toolbar. All right. So, who is going to be talking to you today? Who are your guides through the data? So, rather than just presenting the findings, we wanted to bring in the people who actually built these signals, who actually understand, what goes into these different detections and what's happening behind the data. So, you're going to be hearing directly from the folks who can tell you why they matter and, how we build them as well. So joining me today, we've got Hani Katsevman, who's a technical product manager, who's going to walk us through our browser and network signals, including things like VM, browser tampering, and proxy. And then we also have Aliona Naidenko, and she's a technical product manager as well, who will be covering our mobile signals, thinking about jailbroken, emulators, and app cloning. Now, before I hop into the findings, just want to take a second to explain what the report is. Many industry reports are often, surveys asking professionals, security professionals, risk professionals, what they're seeing. But this particular report is actually built on our identifications. So it's over 23 billion identification events, and these are usually at the moments where, a site is wanting to bump up their security, maybe prevent fraud. Think about logins, signups, checkouts, account recovery, things like that. Anytime a website or an application has requested Fingerprint to identify a visitor. We looked at over, 264 different countries, billions of unique devices, and we've distilled that information down based on these different signals and fraud signals we've seen. Now, this report covers three environments. Like I said before, we've got web and mobile. So our browser or our JavaScript agent identifies browsers, and then our mobile SDKs identify applications, both on Android and iOS. And then just one thing that's worth mentioning before we dive into the data, we're looking at per customer medians. So we're not looking at averages or totals. We're looking at numbers that reflect a typical deployment experience, and instead of having, our larger customers maybe skew these numbers. So what kind of data can we expect to see throughout this report? Here are a few highlights. We saw that VPN usage hit around 19%, so it's roughly 1 in 5 sessions. We saw browser tampering nearly doubling year over year. We'll talk more about that. We also saw that 71% of browser-based identifications came from mobile, right? Mobile continues to be a strong environment. And then we have 13% of Chromium desktop identifications running in virtual machines. So these are just some of the highlights of the things that we're going to get into more as we go. Before I jump into the data, though, I would like to get some data from you. I want to know who's in the crowd. What are the kind of things that you are thinking about? What are your concerns? And this will help me as well as our guests today, our two PMs, to kind of tailor the presentation to make sure it's most valuable for you. So first thing I'm going to do is hop into our first poll question here. So I would love it if you guys could just take a quick second and let us know, what are your biggest fraud challenges today? What are some of the things that you are seeing? So go ahead and just pop in your response there. We've got a few options. Things like false positives. Are you upsetting your legitimate customers with your fraud strategy? Are you looking at automation, for example? Or is it human-like abuse, but it's not really, who knows? Things like account farming, multi-accounting, new account fraud. Are you looking at location trust or geographical abuse? Folks saying they're places that they're not actually in. Or are you just trying to keep up with the latest, evasion techniques and trying to detect abuse early? So go ahead. I see about half of you have gone in. I'll give another second here for folks to pop in that poll. All right, great. Let's take a look at the results. Oops, somebody snuck in right at the last second there. All right, so let's see. Looks like the most popular answer here was the false positives. Yeah, followed by the account farming and then just detecting abuse early in the flow. Yeah, a false positives I think is definitely a big one. We want to make sure things are secure, but we don't want to, upset our legitimate customers and users as well. All right, let's get through these quick questions quickly. So that was number one. Number two, I want to take a look at, what industry are you guys in? I know we got folks from all over the place, but we're just curious to see who is on the call with us today. Some of these signals are going to be more relevant to certain areas, certain types of fraud. So I'd love to hear where you guys are working. And I very much appreciate how fast you guys are getting with these poll responses. The faster we can get through these, the quicker we can get to the data. So I very much appreciate that you guys are pretty on top of it. All right, that one was even faster than the first one. Okay, let's go ahead and end that one. And let's see here. Okay, so this one we're looking at, most of our folks here are in fintech or banking or gaming or iGaming. And there's a lot of you in other. I'm gonna have to update my poll questions to see if I can add some more options here. I'm really curious what the other ones are. But thank you guys. We've got a lot about folks in e-commerce, fintech, and gaming, gambling and gaming. Love it. All right, we got two more to go. Question number three. This one is really focusing on the signals that we're going to be talking about today. Are there signals that you are concerned about? And if there's not here, go ahead and put something else there at the bottom. But are there things that are keeping you up at night? Are there things that maybe in your environment are really tied to fraud? What are the signals that you are particularly interested in or concerned about in your own platforms, in your own environments? Again, great job, guys, with the responses. I love that they're coming in fast and furious. I'll give it a few more seconds. This one you might have to think about a little bit. There we go. We've got about 50% or so participants. All right, one more second. Okay. And let's see here. Okay. Yeah, definitely the automated and bot traffic. Ooh, but also VPN and proxy abuse for sure. And then coming up after that, we've got browser tampering. So we'll go through all these signals today, and we'll talk about, what these things detect and where they are best used for fraud detection. All right, our last one. Here we go. Let me make sure I stop sharing that first one. There we go. Question four, our last question before we hop in. How mature is your signal strategy? We talked about all these different signals. Are you just getting started? Are you looking at maybe one or two different signals? Are you guys fully in on full risk scoring? Where are you at right now? I'd love to know, how many signals are you incorporating into your fraud strategy? And just at the first glance here, we've got some folks. It's a wide variety. Go ahead and keep entering your questions here, your answers. I'll give a few more seconds to let folks hop in. We've got about half of you in so far. All right, few more seconds. Okay. All right, so let's take a look at this one. All right, I'm glad to see you've got about 36% of folks doing full risk scoring across multiple signals. Love to hear that. And for those of you who are just getting started, you are at a great place to learn more about the signals that might help you to build out your fraud strategy. Well, wonderful. Okay, thank you guys so much for that information. So let's go ahead now and hop into our first signal. So we're going to start off with our browser signals. These are things that are happening in web browsers, specifically things like, folks doing browser tampering, browser bot detection, developer tools being open, those types of things. So I'm going to hop in for the first one, which is going to be our bot detection. So first of all, I want to be very clear about what we're talking about with our fingerprint bot detection. So our bot detection specifically identifies browser-based automation, right? We're talking about things that actually reach your website, tools that behave like real browsers that execute, JavaScript or some kind of scripting. This is not network layer detection, right? We're not talking about CDN layer detection. We classify these bots, whether they are good or bad, good being things like well-known search engine crawlers, monitoring tools, that kind of thing. We also have started recently to classify AI agents, AI assistants, AI tooling in general, so we are broadening this categorization as well. Now, how do bots relate to fraud? This one's pretty obvious, but for bots that are actually reaching fingerprint detection, these have already gone through network filtering. They've already gone through CDN rules, your web application firewall controls, your WAF. They've already gone through those. They've gotten all the way to the page, and now they're trying to act like a human, right? They're trying to maybe evade your other detection techniques. Now, this type of automation is often used for things like credential stuffing on login flows, fake account creation at sign up, promo and bonus abuse, scalping, those Pokemon cards that are really hot right now, content scraping, that kind of thing. That's what these are looking at. So we built this signal to basically give customers a clear API-friendly verdict on whether traffic is automated. And crucially, to distinguish between benign automation versus malicious automation. So our bot detection specifically, right, we said we have our customers, they're already using tools like CDN or WAF level bot controls, but on top of that, actually, so if we take a look at the numbers here, you can see we got about 5.5% of raw detection. That's happening after the CDN, after the WAF controls. And then on top of that, we also offer our customers request filtering. So you have the option to turn off filtering against, or turn on filtering, I should say, against things like search engines, AI crawlers. You have the option to say, hey, we don't need you to identify these visitors, right? We already know who they are. We can turn this off. So after they've added that filtering, we then get down to just about 1.4% of our identifications are showing these remaining bots. And of those, 91% are classified as bad bots, right? Things that are trying to likely do abusive techniques or malicious behavior. Then we also see that this is overwhelmingly seen on desktop Chromium. If you have talked about bot detection, if you've looked into bot detection, if you thought about this in fraud in any sense, it shouldn't be surprising to you that desktop Chromium, compared to things like Firefox or Safari or mobile browsers, are definitely the highest rate, right? It's one of the easier browsers to manipulate. There's a lot of builds based on Chromium that are used for scripts and automation. So as you can see, about 8.7% of those identifications are bots when we look at just desktop Chromium. All right, so that's just a quick overview of how this talk is going to go. We're going to talk about what each signal detects, how it relates to fraud, and maybe give you some details about how, to detect it, how we're detecting it. And for the rest of these browser signals, I'm going to be bringing in our technical product manager, Hani. So, Hani, if you want to go ahead and come on screen, there she is, looking great. We're going to hop into our next signal here. And again, if you've got questions on these signals, please go ahead and put them in the Q&A, and we'll go through all the signal questions at the end as well. So make sure you're taking those Q&A questions down. But we're going to hop into virtual machine detection. So we saw 13% on Chromium desktop of our detections coming through virtual machines. Hani, can you tell us more about what this signal does and what it detects?
Sure, Kisha. So, virtual machine detection, it tries to identify sessions that are running inside a virtual environment instead of a regular physical device. So basically, where the device setup look virtualized rather than like a normal user laptop.
And how does this then relate to fraud or abuse?
That's a good question. So fraudsters commonly use virtual machines because let's take an example. It will be easier. If someone wants to create hundreds or thousands of accounts, using real physical device for everything can become expensive and hard to manage. With virtual machines, they can quickly create separate environments, reset them, copy them, and switch identities more easily and effectively.
Okay, and then why did we add this signal?
So we added this signal because virtual machines commonly used in many types of fraud and abuse flows. Um, let's just provide some quick examples. So it can be creating media accounts, it can be promo or bonus abuse, bot activities, and much, much more. They're also often combined with tools like residential proxy and browser tampering, which we'll also kind of cover later. Together, these tools help attackers make their traffic look more real, more distributed, and harder to connect together.
Gotcha. And has this signal, the way we detect it, has it changed over time?
Oh, yes, quite a lot. So at the beginning, the detection was based mostly on simple signs. These signs were related to virtual machines or known VM software. The main goal um, at that phase was to avoid false positive, even if that meant detecting less VMs. Then I think it was early 2025, we introduced new research findings that really improved detection. That help us move beyond detecting only known VM software and start identifying virtualization at the hardware level. Today, we're taking another step forward with ML-based VM detection. So instead of relying only on fixed rules, we're now combining many different signals into one ML model. This gives us better coverage, higher accuracy, and make detection harder to bypass. I will say that this right now is in beta. So if you're an existing customer of Fingerprint, you can reach out to your CSM or to support and ask to be part of that. But if you're listening to a recording of that, that will probably be available to everyone in a week or two.
Oh, great. Now, so we see, here in this data that 13% of the desktop Chromium detections for virtual machine. And when we look at any of the other browsers, like I mentioned earlier, that, these browsers really not seeing too much happening in those other ones. Now, can you maybe explain maybe what are some of the legitimate use cases for VM? At what point when looking at this data, whether you're a Fingerprint customer or not, at what point does this become a red flag?
Yeah, excellent question. So as you mentioned, there's a lot of legitimate VM use cases. It can be developers and QA, it can be security teams, it can be enterprise customers, and maybe let's break down each. So for developers and QA, they can use VMs for testing. So let's think of a company. They want to verify that their recent development behave across different operating system, different browser version, different device configuration, or just an isolated clean environment. So instead of buying 10 physical machines, they spin up multiple virtual machines very quickly. Also, we have security teams. They often open suspicious files or link inside an isolated virtual environment. So if something malicious happens, it is contained and doesn't impact the actual corporate machine. On the enterprise side, we know that a lot of organizations use virtual desktops for remote work or security isolation. So instead of employees working directly from a local device, they connect into a centralized virtual environment hosted by the company. That is especially common in banking, in healthcare, highly regulated industries. And in those cases, virtualization is actually part of the security model.
Got it. So you always got to think about that context. Yeah.
Exactly.
Well, let's hop into our next signal here. I think this one also has a lot of implications around context as well. So we saw for our developer tools, 6.2% of our desktop browser identifications had developer tools open on load. And it goes a little bit higher when we specifically look at desktop Chromium here as well. But tell us more about what this signal detects.
Sure. So that's quite simple. We detect when a visitor browser developer tools are open when our JS agent collects the data.
Great. And then how does that relate to fraud then?
So as you mentioned, it is, as I like to describe it, a high context signal because there are many completely legitimate reasons for somebody to have DevTools open. As I mentioned before, developers and QA, this time they can be debugging websites, inspecting console errors, testing UI behavior, things like that. Also, we have security research at IT teams. They can troubleshoot or doing some security analysis. But in abuse-related workflows, it's very common used during different type of activities. And maybe just to mention some, so reverse engineering on the client-side logic, inspecting network traffic, manipulating browser API, So the issue is not DevTools itself, because again, many normal developers use it. The interesting signal is usually how it's being used and whether it appears together with other suspicious identifiers, like automation, tempering, proxies, or VM usage.
Right. So then why did we add this signal?
So developer tools are often used in heavily modified or controlled browser sessions. We know that many fraud and abuse flow involve interacting directly with the browser. So as I mentioned previously, inspecting requests, changing browser behavior, manipulating browser API. And this became especially relevant in areas like identity verification or KYC flows. So we know situations where an attacker may try to fake or manipulate the browser or even the camera behavior during verification. There are also scam scenarios where victims are told to open developer tools and expose sensitive browser or session information. And as mentioned, the goal of the signal is not to say that using DevTools means fraud. Instead, it gives our customer more visibility into sessions that might be more manipulated or controlled than normal user traffic.
Yeah, and some of those scams of what is the tech assistance scams are like open up your dev tools. Yeah. Mm-mm.
Exactly.
Oh,
Exactly.
goodness gracious. Oh, all right, let's keep moving to browser tampering. So again, staying in our browser signals category here. In this case, I thought this was one of our more interesting updates. And we see 4.4% of our uh, browser identifications showing signs of tampering. And I mean, 4.4% doesn't feel like that big of a number, but the fact that it nearly doubled, maybe saying nearly doubled is a stretch, but still 2.6% the year before, going up now to 4.4% in, desktop browsers. What is this browser tampering signal really trying to detect? What are we actually seeing here?
Yeah, so I have a lot to tell you. It's one of my favorite signals.
Oh,
So browser temper, we are detecting browser environment that appear intentionally modified to hide identity or avoid fingerprinting. At a high level, we look at two main things. One is known patterns linked to different anti-detect browser. And second, inconsistencies between the browser and device attributes that normally should match on real devices. So let's take an example. If different parts of the browser environment report unusual or conflicting information, it can suggest that the environment was modified artificially. So overall, in a sentence, the signal tries to answer a simple question of, does this look like a normal user device, or does it look intentionally manipulated?
hmm. Okay, I think I know the answer to this question, but how does this relate to fraud? Why did we want to bring this signal forward?
Yeah, so browser tempering is often used to hide, to change, to rotate identity online. Many fraud systems rely on browser and device consistency to recognize user or to detect coordinated activities. So when someone intentionally changes the browser behavior, the goal usually to make the session look unrelated, more legitimate, and harder to connect together. So in many cases, this is done to make a large-scale activity look more normal and harder to detect.
Gotcha. So if you're detecting, some kind of tampering is happening, what are our customers or anyone, again, because these are signals, obviously we provide these signals, but you can also do your own detection. What do our customers do when they detect this tampering? Or what should they do?
Yeah, so it really depends on their customer risk tolerance and user flow. In many cases, customers don't immediately block users based on these signals alone. I would say any signal, but maybe there are exceptions. Instead, they use them as additional risk identifier. So common actions can be increase risk scoring or trigger a setup verification or MFA, limiting maybe certain actions, rotating users into additional review flows. I just went on a call with a customer and talked about that specifically. So he mentioned that if it's a clean user, that's a normal login. Well, it's a suspicious signal like tempering, they just require additional verification before continuing. And specifically for anti-detect browser, that it's part of the tempering signal, some customers may just ask their customers, the end users, to switch to a more standard browser.
So it seems like maybe you weren't doing anything suspicious, but you're using a well-known suspicious browser. Go ahead and hop
Exactly.
over to something a bit more normal for this
Yep.
sensitive transaction, for example. Gotcha, gotcha. Wow. Yeah, I'm very curious to see how this continues throughout the rest of the year because, it seems like the majority of the time it is leaning more towards suspicious, fraudulent behavior. And if it's, growing this fast, it's definitely something that people will need to keep an eye on in their own fraud strategies. All right.
Definitely. We have some really great plans on that as well. Oh, yeah.
Nice. All right, thanks, honey. You can hop off for now. We're going to swap into our mobile signals with Aliona. There she is. Wonderful. And we're going to be looking at things like rooted and jailbroken devices, emulators, and app cloning. So, starting off with rooted and jailbroken devices, these tend to be somewhat similar, but you'll notice we're seeing a lot smaller percentage numbers here, right, Aliona? But can you tell us, before we even get into the numbers, what exactly are we detecting here with rooted and jailbroken devices?
Sure. Hello, everybody. Nice to see you all. Yeah, I'm happy to walk you through rooted and jailbroken devices more and also share this idea why we see these differences between Android percentage and also iOS percentage for rooting. So let's start with understanding, right, what rooting is. So root access is basically full control over the Android device, if you're talking about Android first. Because on the normal Android phone, applications live in sandboxes. So they can't touch each other's memory or mess with the operating system. But rooting tears down those walls by granting a user or Android application unrestricted super user access to Android operating system. To better visualize it, so we can imagine it's like getting a master key to a building that was designed so each tenant has their own door key, but with master key, you can steal anything, you can go into any room and do whatever you want. So Fingerprint detects this through combination of different checks. So for example, presence of particular binaries, known root management application like Magisk, for example, modified system properties, suspicious build properties, and much more. Speaking about jailbreaking, is basically equivalent for rooting on iOS. Means breaking iOS core security model because iOS is much more locked down than Android by default, and jailbroken iPhone is much bigger anomaly than a rooted Android. Also, if you're speaking about countries like India, for example, Android devices are much more popular there than iPhones. And also for fraudsters, to buy, I don't know, hundreds of real iPhones, it's expensive. So it's basically, that's why jailbroken iPhone is expensive even for fraudsters. So that's why this percentage is smaller if you're talking about a bigger picture. So yeah, this is about jailbreaking and rooting and what is it.
Yeah, that makes a lot of sense. Can you tell us then how this relates to fraud? Because you mentioned, that many times people might be rooting their device just normally, but how does it then show up for fraud situations?
So rooting is always near universal precondition for any advanced mobile fraud because you can't hook application memory or spoof identifiers or strip security checks without it, especially on iOS and also Android as well. So if I took one example, for example, because we have audience from fintech and iGaming here, so an attacker can root their devices and then they can hook into bank application memory with some reverse engineer tool, for example, FIDA. And after that, they're able to intercept one-time password before even it reaches the screen. So user, they don't see a code yet, but fraudsters, they already get this code. So that's why they can forward it to complete an unauthorized transfer, for example. That's why it's crucial to detect rooting and jailbroken devices.
Wow. And has these signals, I should say, two signals, have they changed over time that we've, been detecting them?
For sure, because like routing detection and jailbreaking detection was one of the Fingerprint's earliest mobile smart signals. Because as I mentioned, so rooted device is a prerequisite for many fraud techniques. And basically a lot of jurisdiction and a lot of countries, they kind of mandate to block rooted devices and restrict those requests coming from the users. So that's why speaking about how these signals change over time and how we enhance this. So it's always an ongoing arms race for us, because tools like Magisk, they can hide root artifacts, but show in application a fake view of operating system. So that's why it means we constantly adapt and improve our detection to keep up. We also work tightly with our research team to find better raw signals we can combine, for example, and detect direct routing to decrease and because we are very careful about false positives here, because we want to detect direct routing, not something like routing, because we understand that for some compliance and regulatory reasons, it's very important, not to have false positives here.
And yeah, you're right. That was one of our top concerns from our poll earlier. It's like, yes, we want to be secure, but we also want to make sure that we're not, having those false positives and tripping when things aren't really there. Absolutely.
Exactly.
Let's hop into, our next signal here. And these next two are kind of similar, but we're going to start off with Android emulator. You kind of touched on this a little bit, thinking about maybe earlier we were talking about how many times people want to get, iPhones or Android phones and try and have all these multiple phones to do different types of fraud. But first, let's just define what we're looking at here. So here we've got 0.37%. Again, you can notice much smaller numbers for detections on mobile. But tell us, what are we looking at when we're thinking about, Android emulator detection?
Yeah, so for emulator, so emulator basically is a software that pretends to be a mobile device. It runs Android or iOS on a desktop or cloud machine instead of real hardware. So for developers, as Hani talk about virtual machine on desktop, right? So for developers, simulators, emulators, they kind of a legitimate testing tool as well on mobile. But for fraudsters, they're a factory, because one server can run hundreds of fake phones, right, simultaneously, each with its own identity. So that's why it's crucial for us also to detect, to be able to detect those emulators. That's why we are checking for emulator-specific build properties, absence of expected hardware sensors. So, for example, no gyroscope, no real battery, combination of some hardware things, also known emulators, binaries and files, and time-based anomalies when we're speaking about sensors data. Because, emulators, it's a tricky thing, because fraudsters, they can do a lot with real device, but with emulators, they can spin up to 1,000 instances and commit scale fraud.
So what exactly are they doing with these thousands of emulators? What kind of fraud would you say?
So basically, let's take an example again with the fraud ring, because right now, when I open LinkedIn, I always see a lot of fraud rings, how we can detect it. So a fraud ring, they can spin up 500 emulator instances, and each instance has a spoofed device ID, and it can have a fresh email address. And if you're talking about iGaming application or some bank application, usually they can do some promotion or provide some bonuses for their users. So all those emulator instances, they can claim a new user bonus from the app. Then the money are funneled to a single withdrawn account of a fraudster. So at the physical scale, this would take 500 devices, like real devices. But with emulators, it takes one afternoon of a fraudster's work. So that's why it's very related to scaling fraud, to bonus abuse, and all those things.
Anytime you want to pretend like you're a new user, basically, look like a new
Exactly.
person. Oh, of course. Has this signal, the way we detect it, has it changed over time?
Because right now we get like a lot of commercial emulator farms, let's say, and they offer very sophisticated environments specifically designed to pass different mobile fraud checks. So they can inject realistic sensor data, they can spoof hardware identifiers. So our detection has shifted from simple property lookups to multi-dimensional consistency checks, especially on Android, because again, Android, it's, I guess, my favorite, operating system, because there are plenty of options to customize the Android device just for daily usage. A lot of people, they just buy cheaper Android devices and then just customize it by adding more memory, changing some configs. And for them, they just use it for daily usage. But, we need to, again, speaking about false positives, we need to understand whether it's legitimate user or it's kind of emulated environment. So let's make us tricky, but also interesting, to detect those things.
Yeah, and I think the next one we've got here, app cloning, is a similar idea, but just like in a different way, right? So tell us more about this. We saw about 0.16% of our Android app identifications showing signs of app cloning. Now, the term app cloning could mean a couple of different things. So what exactly are we talking about here?
So app cloning, yeah, you're right that we are can talk about different things, but cloning tools on Android, they create isolated copies of the application that run side by side on the same phone, and each of these copy, they have separate storage account and also identity. So from the service perspective, they look like entirely different devices. So our detection question isn't, is it a bad application? So our question is this application running in the environment it was actually designed for? So one of the fingerprint detection consists of analyzing device level signals here to determine whether the application is running in its original intended environment. When anomalies are identified in the device configuration, they we are treated as a potential indicators of cloned application usage. Yeah, so this is it
Yeah,
about
and
app cloner.
yes, and I think the use cases here for fraud are probably pretty similar to the Android emulator, right? So like, how does this relate to fraud?
Yeah, so as cloning lets a single device operate in multiple accounts in parallel, it's heavily used for multi-accounting, also referral, bonus abuse, farming rewards, etc. So we added this signal because app cloning breaks device level fraud, as I mentioned, device level fraud controls, as I mentioned. So in case our existing customers or our potential customers are limiting accounts or actions per device, cloned application let multiple instances share the same device. So we do think it's crucial, to flag this and to mark that this seems to be a cloner.
So this particular signal right now, we're really only focused on Android. Is there an equivalent behavior to this for iOS devices?
Thanks for this question. So for iOS, there is no native multi-account or app cloning capability for third-party applications because Apple uh, Apple sandboxing strictly limits it. But in case you have jailbroken iPhone, basically it's possible to use tools like AppSync Unified or duplicate application installers on the jailbroken devices, and then you can sideload multiple copies of the application and have different bundle IDs on iPhone. So basically, it's the same outcome as Android cloning, but Android cloning doesn't require rooting, right, on the Android device. For iPhone, it requires first jailbroke to have jailbroken device, and then create those multiple copies with multiple bundles ID. But direct equivalent for app cloning on iOS, it doesn't exist because of Apple restrictions.
Gotcha, gotcha. That makes a lot of sense. All right, thank you very much. I think we've got our next section coming up. Yep. All right, we're going to swap over to Hani, and we're going to take a look at our last section here, which are our network signals. We're thinking about things like VPNs, proxies, things that are happening over the network themselves. Welcome back, Hani.
Happy
Our
to be here.
first, I'm so glad that you're here. I'm glad that both of you guys are here. This is a great webinar. Our first signal here is for VPN, and I shared this at the beginning just to give a highlight that we saw 19% of our identifications showing up as VPN through VPN. That's 1 in 5 sessions. And then we break it down, we can see that for desktop Chromium specifically, that jumps up to about 33%. And then we still even see it for our mobile, because again, this is a network signal. So for mobile, whether it's mobile browsers or mobile applications, we're still seeing about 13%, right? But overall, 19%, 1 in 5. I think most people know what this one is, but let's go ahead and give a breakdown of what we're detecting here for our VPN detection.
Sure. So we're trying to identify traffic that is likely coming from a VPN instead of a normal home or mobile internet connection. The signal uses different network and device indicator to estimate whether the traffic looks VPN related. And some common indicators that we use, if it's a known VPN server, time zone mismatch, that means if the browser time zone doesn't match the IP location, relay or routing indicators, suggesting the traffic is just being redirected. And there are also cases where the device or network behavior simply doesn't look like a normal direct consumer connection.
Gotcha. Now, I know VPN can be used for all kinds of things. I have a VPN, I'm sure many people have VPNs for their personal use as well. But how does VPN relate to fraud?
Yeah, that's a really good question because with VPN, they make it harder to understand where the traffic is really coming from. So in many cases, VPN usage is completely legitimate for privacy, for security, or remote work. But in abuse scenarios, the VPN can be used to create accounts from different regions, hide the relocation of the user, reduce the effectiveness of IP reputation systems. So it really depends on the industry. And as you mentioned, the concern is not always fraud directly. So, for example, we have streaming platforms that might need to block access from restricted regions, or online casinos that may only be allowed to operate in certain countries. Or, last one, I promise, financial services may need higher confidence in location verification. So, overall, the signal helps customer better understand how consistent and reliable the network connection looks, rather than treating VPN usage itself as malicious.
Hmm. So why did we add this signal?
So, as I mentioned, the network origin and location trusts are important in many fraud, in security, in compliance use cases. So, beyond fraud, many customers also want to understand whether traffic is coming from a normal direct internet connection or an infrastructure that hides the real location or origin. And it's especially important in industries with geographical restrictions, compliance rules based on location, network trust policies. So overall, as I mentioned, the goal of the signal is to give customers more context about network trust and location reliability. It helps them make better risk and policy decisions.
Great. And then our next signal here, our last signal for the day, very similar, but this one we're seeing for global identifications for about 20% coming from devices using some kind of proxy. And we've got a couple different types of proxy identifications, but we saw 31% for Android, 25% for iOS, and then for our web browsers using the JavaScript agent, about 19.8% there. So tell us more about, proxy detection, maybe some of the types of proxies that we're detecting here.
So the proxy signal detects whether the IP is linked to a proxy infrastructure, meaning the traffic is likely being rotated through another service instead of coming directly from a normal home. And we know that fraudsters often prefer proxies because they're easier at scale. It's making more cheap and efficient to manage large amount of abusive traffic. There are also another reasons. I can answer them now or later when we talk about fraud. But I think the main shift that we have done is to move from data center proxy to residential proxies, because we are moving together with the fraud, or in better scenarios was moving before the fraud happens. So I think that was the major shift in terms of the proxy type.
Yes. Okay. So you mentioned residential proxies, and there are all kinds of different proxies. So how do those relate to fraud? Maybe folks aren't familiar with residential proxies and how they're used.
Yeah. So in terms of that signal, I think that network trust is still important part of fraud and abuse. And as I mentioned, attackers became much more sophisticated in how they hide or rotate their network traffic. So instead of coming from obvious data center services, a lot now coming through residential proxies or mobile networks. And it looks just like normal user traffic. So with this signal, we help customer understand whether traffic looks like it's coming from a normal direct connection or through infrastructure that may reduce trust in the network origin. In the end of the day, the value is giving the customer more context. So it's not only proxy yes or no. We have added much more context to that signal so they can make better risk and trust decisions.
Gotcha. Great. I think that that's our last signal for today. Let's go ahead and have Aliona come back on as well, and just to take a few takeaways here. So, just from what we've been chatting today, it seems like there are a few things we can say. VPN, as we saw, is no longer a niche thing. I think people kind of knew that, but now we've got the data to really back it up. 1 in 5 identifications using VPN, definitely not necessarily a instant fraud indicator unless it's important for your particular use case or environment. We saw from the data again that mobile signals are really rare, but I think that also makes them a bit stronger sometimes, right? It's a little bit easier for you to say, yep, this is suspicious, and maybe we should block or alter the way we're handling those transactions. Desktop is the automation battleground. Time and time again, desktop, especially desktop Chromium, seems to be the place that, these tools are being made that people are using for fraud and abuse. And then as we've been seeing throughout, you guys have even mentioned it, that, we need to combine signals together, that no one signal is necessarily going to say, yep, that's fraud. We want to be able to look at context from multiple signals across the way. And then lastly, as we prepare for AI agents as well, we want to think about what do these things look like when we're talking about bots and automation that are now being used for perfectly legitimate things, right? Some of these things, again, are not necessarily bad on their own, but how do we think about intent overall? I'd love to get a few last questions from you guys here as well. We talked about it a little bit. I just mentioned here about how the VPN baseline has changed, normal has shifted. How can we think about recalibrating what suspicious means? Hani, could you hop on that question?
Yep, we'll be happy to. So I think one of the biggest changes for fraud teams is understanding that individual signals they're not automatically bad anymore. So a few years ago, as you also, Kisha, as you mentioned, seeing a VPN on or unusual browser behavior was rare or highly suspicious. But today we know that many of these behavior are part of the normal internet usage. So Kisha, as you mentioned, you have a VPN. I also have VPN, so they're widely common. Privacy-focused browsers are growing. Virtual environments are used by a lot of big companies. So today, unusual doesn't always mean fraudulent. And instead of looking at one signal alone, fraud teams increasingly need to look at the full context and combination of signals. So let's take an example. A VPN alone may not say too much, but a VPN together with tempering, automation, and suspicious account patterns became much more meaningful. And I will say, as I mentioned before, we're always trying to move together or even before we see a lot of fraud. So we're currently building a very new feature. It is so new, we even don't have a final name yet, but I will try to explain without mentioning just random names, where basically our customers can upload their fraud labels. We will train an ML model using all the information that we have, so exposed and not exposed signals. And then for every request ID, we will generate a single score based on all the combined context we have. So that will exactly help to do that zoom out approach rather than looking at a specific signal. I will state just a little bit more information in case that interests somebody. We're planning to start the beta soon. During the beta, it will be free of charge. Later on, it will be charged. So if anyone here is interested, please feel free to reach out to your success manager or support, and we will be happy to add you to the waiting list.
Awesome. And I'm going to pull on that a little bit more. Maybe Aliona, I'm curious. You just talked about, Hani talked about a new signal that's coming out. What other signals are coming soon, Aliona, that we can be excited about?
Speaking about mobile, like last month, we just released iOS simulator detection. So we spoke about Android emulator detection that we have. So right now we also support simulator detection on iOS. That's why I will be curious to see, the results in a year after we got the new report, and we can compare and see new percentage, especially for iOS traffic for simulated environments. Also soon we will be releasing DevTools detection on mobile for both platforms, Android and iOS. So to have this parity on web tools detection as well. We also will be releasing this on mobile. And also we're working to improve our routing detection on Android, and new enhancement will also be released in the end of the month or early June. So a lot of interesting enhancement coming out on mobile. profile. So yeah, happy to be the part of this.
Awesome. Yeah, maybe in next year's report we'll get to see some new detections, some new
Yeah.
things that fraud teams can take a look at and be mindful of. Yeah. Speaking of things that fraud teams should be looking for, Hani, I'm curious, are there any last things you want to mention as far as like what fraud and risk teams should be looking for when they're thinking about detecting suspicious visitors?
Um, so yeah, I will mainly say that I think the biggest shift is there's no really magic signal anymore. So motor abuse operation are much more sophisticated and much better at looking legitimate. So the most effective approach, as I see today, is combining multiple signals and looking at the full context of the session. So it can be VPN proxies, environment integrity like tempering, anti-detect browser, or as Alona mentioned, rooted device or emulators. So the bottom line is more context than a specific use case. Um, yeah, I can share maybe a specific example and then share about another feature we're working on. So I can say that for one customer, we know that the most meaningful signals might be proxies or bots. For others, it can be anti-detect browser and tempering. So it really depends on the type of abuse they're dealing and their own traffic patterns. And for that, we have already released suspect score recommendations where our customers can upload their fraud labels and we will run the ML model on smart signals, the ones that we're exposing today. Then our customers will receive back the weights for each signal and the threshold that we will recommend. So they will know based on their own fraud patterns what should be the weight for each signal and what should be the threshold. So it's brand new, and we're really eager to receive as much feedback as possible. So yeah, if you will try to use it, let me know how it goes.
All right. Well, I think that's good for now. I've got a couple of questions here in our Q&A. I can answer one of those questions right now. One of the questions is, how can we get access to the report? So here you go. Here is the link. Actually, let me also grab a link for you guys here as well, so we can have that going. And you can go ahead and if you want to use your mobile phone to do the QR code here. I know that that might not be the best of options. Let me see. Why is my computer? Come on now. Of course, now it wants to act up. Here we go. I got the link. I'm like, come on, get with the program. There we go. Wonderful. So I'm going to go ahead and put in the chat here so everyone can see it. We have the link for the device intelligence report right there. You can go ahead and take a look at that. It'll include everything that we covered today, as well as more detail. It goes into further breakdowns of, the different platforms, different browsers, different mobile devices, environments. It also goes into regional differences as well. And there are a few more signals in the report that we didn't get a chance to cover today as well. So you can go ahead, grab that by either scan the QR code on the screen or the link in the chat if you want to hop in to look at the data in more detail. But at this point, we've got a few more minutes left. So I'm going to open it up to some Q&A. And again, feel free to put your questions in the Q&A box. I saw a couple questions in there already. I'll go ahead and answer those and we'll meter them out to either Hani or Aliona. But if you've got questions about Fingerprint or about any of these signals, even if you're not a Fingerprint customer, while of course we're always going to say use Fingerprint, but honestly, many of these signals you can try and start to detect if you have the resources, and you should be detecting them even if you are not a customer. So if you've got questions about those detections in general, let us know in the Q&A. But I've got a question here. I think this was about our suspect score. We didn't actually get a chance to talk about our suspect score here. But Hani, you kind of talked about it a little bit overall as far as what the suspect score is. Can you just give a brief overview of suspect score in general?
Sure. So our suspect score started as a feature where you can see the default values that we would recommend for all the customers for each of the signals. And then based on the suspect score that you will receive with every visitor ID, you will be able to do different actions on your end. I think the most exciting part that I just previously mentioned is suspect score recommendation. So now once you upload your own fraud data, we are able to say, okay, VPN should move from being labeled as 10 to 15 based on your own data, while proxy was previously 15 and should be now 27. Again, just throwing numbers to the air. One of the other things we're doing, besides the weight themselves of the signal, we are suggesting the threshold. So I saw one of the questions was around the threshold being 0 for one of the customers. And in that case, I would highly recommend to try that feature, because we do know that some signals are legitimate in a lot of the cases. And then flagging it may just create some noise. So if you will upload the data, you will be able to see the weight, and then you will understand what should be the correct threshold for your own data and workflow.
Great. And just so everyone has, because I know that our audience does not have access to the question. So the question here was that they use suspect score, and if the number is above 0, so remember the suspect score is just that one signal number for all of our signals. If the number is above 0, then we do request the identification, but we only do so on the first page load. Does it make sense to re-request identification after a couple of pages so that Fingerprint could collect more information? So, Hani, do you have any input on that of when you should be maybe making those identification requests so you can maybe make those decisions based on suspect score?
Yeah, so I will recommend to kind of separate two things. So we have visitor identification and we have the signal collection. So while identification is a separate product, I can say from my general knowledge that the visitor ID is generally stable across the sessions. So if you identify the same visitor at the first page, re-requesting identification later should usually return the same visitor identity. That said, with some smart signals, it really depends on the risk context. So it will make sense to rerun it at higher risk flows. So let's say checkout, withdraw, something that it's more sensitive, because then we can just maybe get more signals collected. Maybe the user changed something, or if it's a fraudster, they changed something in the behavior, and we will be able to provide you with a little bit more data.
Right. So if I'm checking someone, if I'm identifying someone throughout their session, that visitor ID that doesn't necessarily change, but maybe they've turned on a VPN, for example, right? Maybe they've opened up dev tools and now those signals have changed. So it makes sense depending on the action to do it again. That makes sense to me. Great. Let's see here. I've got another question in here as well. Someone's asking, what trends are you seeing in residential proxy abuse? I think this is back to you, Hani, again.
So I'm just trying to maybe understand when you mentioned trends, what exactly do you mean? I will try to answer, and then if not, maybe you can just submit another question. So in terms of how fraudsters kind of use proxies, why they prepare them. So as I mentioned, general residential proxy are easier to scale. They're cheap, they're efficient. That's helping rotate IPs. So it helps them to bypass IP bands. They're constantly changing the IP address. They're changing the location. So the automated activity are much harder to block. And I will say that we commonly see them with tempering or anti-detect tools and automation because it really helps the device to look more unique and legitimate. It just helped the attacker to avoid detection and make large-scale activities harder to connect together. So hopefully it answered the question. If not, let me know.
Yes, if you want more clarifying question, go ahead and put it in the Q&A there. Let's see. I think I saw a question actually in the chat. Let me make sure. Here we go. Yes. Someone is asking, what do you think the biggest future challenge will be for detecting fraud and automated users? I'm going to answer the automated users part, and then maybe I'll pass it to Aliona for the detecting fraud part. I think for the automated users part, since we now have, these AI agents, these AI tools that are able to do tasks on behalf of actual humans, doing these automated scripts or automated workflows. I think the challenge that we're going to see now is that these tools can use regular normal browsers and using computer vision they can manipulate and control them versus in the past you had to use some kind of specialized browser, let's say maybe a headless browser tool like Puppeteer or Selenium, those kinds of things. I feel like the challenge we're going to see now is that these tools are able to kind of control your computer as if they were a human user using regular normal looking browsers. So I think it'll be an interesting shift to see how we can look at maybe not just is it automation, but more so focusing on what the intent of those users are, whether they're a bot or not. Right now, it's more like we don't really care if you're a bot or not, because sometimes the bots are good, but what are you actually doing? What is the intent, and what are the context around those actions? Aliona, do you have anything to add around, maybe some challenges, maybe even in the mobile space or just in general that folks might see in the future?
Yeah, I can maybe like share one example, for example, and challenge when we're speaking about app cloners, right? Because right now we see that app cloners, it's not just one type of thing, because a lot of dedicated clone apps on Android, for example, for like Samsung or Xiaomi, they have manufacturer built dual space features that are legitimate and free to use for all Android users. And also they have virtualization tools that often overlap in behavior like app cloners, but differ in implementation. So we try to, extend our detection in future and maybe separate like app cloners and virtualization tools in mobile to make, the detection more like layered and also help us to reduce false positives and improve context, what is it? Is app cloner or this is virtualization tools? Because I think it would be, one of the future trends when we're speaking about mobile fraud and Android specifically.
That makes sense to me. Hani, do you have anything you want to add here? I think this is our last question for our event here. Anything you want to call out as potential future challenges, maybe in the browser or networking space that you can see?
Hmm, good question. I will say that generally, I think that the shift we're seeing is that fraud operation became much more scalable.
Mm.
So a few years ago, abuse was often just kind of noise and easier to detect. And today, I see attackers blend much more naturally into normal traffic. Um, Another big challenge that I can think of is it feels like fraud is no longer just an individual progress. It became much more of an ecosystem. So the proxy providers, anti-detect tools, automation platforms, and they're like online fraud communities all working together. So I see that as the main challenge. But yeah, besides that, we're doing kind of all we can with all the teams that we have, and to make sure that we are kind of detecting all the fraud that is coming our way or our customers' way.
Yes, it's a constant battle, right? It's
Exactly.
constant race. Well, thank you both for hopping on today and going through these signals. I think people had some interesting questions, and I hope that those of you that joined us today, that you maybe found some new nuggets of information, maybe some new threads to pull. Those of you that are just starting on your signal journey, I hope you've got a good start on things that maybe you can start to look into in your own platforms. But again, if you want to take a look at the report in more detail, get the full rundown, broken down by different regions and areas and different platforms, take a look at the report. And you will be getting the recording of this, I believe, at the end, either today or tomorrow, sometime this week. But if you have any other questions, reach out to our Fingerprint support team. Other than that, I hope you have a great rest of your day, whether it's the morning, the afternoon, the evening, wherever you are. Have a wonderful day and take care. Thanks, guys.